Algebra 1, Lesson 40, Part A is called Quotient Rule for Exponents. We have already been using some rules for exponents, and they are here in the box to review. The product rule says whenever you have a product, when you're multiplying terms with the same base, that you add the exponents. And I can give you an example with numbers just to help that make sense. X squared times x to the third means there's x squared, there's x to the third. There are 5 x's being used as factors. That's x to the fifth. You add the exponents as a shortcut. Okay, and then we have this definition, but I did explain back when we did that lesson, well, that's especially getting down to here. This one we did actually, I explained that in that lesson also. So x to the negative n equals 1 over x to the n. But if you have it as a fraction already, then x to the negative 1 over x to the negative n equals x to the n. That's the same as x to the n over 1. But when it's just over 1, we don't write that part. Cross the line to change the sign of the exponent. Again, the line being the fraction bar. And then also, this says it's the definition, but we were able to explain that one in class. Anything to the 0 power is equal to 1. So these are the rules we've been using so far. We have a product rule, and now we're going to add the quotient rule. Okay, now, so we're going to use what we know already. We have been, actually. To simplify things like this, for this fraction, you can cross the line to change the sign of the exponent. So there's this problem rewritten. And then your product rule says add those exponents. So 6 plus negative 4 is 2. Okay, so our new rule is giving us a shortcut. When this happens, you see the end result is you're doing the top exponent minus the bottom one. Because again, that's understood to be over 1. This one's in the numerator, that one's in the denominator. When you move it, it changes the sign, and then when you're adding, you're subtracting that original exponent from the one in the numerator. So this is our quotient rule. Okay, so m and n are real numbers, so any number, and x is not 0, because we can't be dividing by 0. Then x to the m over x to the n is equal to the x to the m minus n. Because if you cross the line with this denominator, you bring it up, that makes it x to the negative n, and then this equivalent to that. Now also, sometimes, and you'll have to read the directions carefully, sometimes we need the variable in the denominator, and then it's 1 over x to the n minus m. And if you look at it, when you cross the line to change the sign of this exponent, both parts change. That m becomes negative and the n becomes positive. So it switches their signs. And how you can think of it is that if you want your answer in the numerator, you do the exponent from the numerator minus the exponent from the denominator. That's this one. If you want your variable to end up in the denominator, then it's the exponent from here minus the one that's moving. Let's look at some other examples. Okay, example 1. So simplify, and this time we're supposed to write the answer with the variable in the numerator. So we're bringing this one up, basically, is the old way of doing that. Okay, so using this quotient rule, that would be x to the 6 minus 4. If we want the answer in the numerator, when we're subtracting exponents, we start with the one in the numerator, 6 minus 4. That's x squared. Okay, and just to show you, if we did it the old way, cross the line to change the sign of the exponent, That coming up would make it x to the negative 4, and then you have 6 plus negative 4, which gives you the 2. Example 2. This time we're supposed to write it with the variable in the denominator. Okay, so 1 over x, and now we start with the exponent in the denominator, so now it is 4 minus 6. 4 minus 6 is negative 2. So there it is, written with the variable in the denominator. And you see, these were the same exact problem initially. Here it is in the numerator, and if we cross the line, change the sign of the exponent, we get the answer in this one, where it's in the denominator now. Okay, now, example 3 is similar, but we have a sign change here. Now it's x to the 6th power over x to the negative 4. So our quotient rule that we're practicing, it doesn't tell us whether when it's the variable in the denominator or the numerator, so I'm going with numerator. When it doesn't say, I would do that. So we have x to the 6th minus the bottom denominator. So 6 minus negative 4. Minus negative is plus. That means that is x to the 10th power. And you can still also do these the old way. Cross the line, change the sign of the exponent, and then add, just to verify that it's coming out right. Okay, this one's totally abstract. There are no numbers in here at all. And again, it doesn't say where to put it, so I'm going to put the variable in the numerator. I have x. Okay, and the exponent, I start with the exponent from the numerator minus the exponent from the denominator. And there are no like terms or anything. That one's done. Alright, that's all we do for those. Here's one that's a little longer. Okay, so our variables aren't even all lined up, but top and bottom both have x, y, and z. And again, when it doesn't say, I'm moving things to the numerator for now. I'll talk about that in just a moment. So we have, for x, I have negative 5 from the numerator minus, okay, when there's no exponent written, that's an understood 1. And then I have y, numerator's exponent is a 6, and there's a 2, so 6 minus 2, and then z, the exponent in the numerator is a 1, minus the exponent in the denominator is a negative 3. Minus negative is plus a positive. Alright, so I have x to the negative 6, y to the 4, z to the 4. Okay, so I said when they didn't specify which one to use, I went with putting things in the numerator. However, if we were going to have to then evaluate this, given values for our x, y, and z, we do not want negative exponents. So the standard way of doing these when you're not told otherwise will be to end up with all your exponents positive. Alright, it's easiest, I think, to just start out moving everything up, get it all simplified, and then see, do I have any negative exponents? If so, I'm going to move them back down. Alright, so y to the 4th, z to the 4th, over x to the 6th would be equivalent. Okay, either one of these is fine. If I'll circle either one of those. Since the directions did not specify where they want variables, they may say with all exponents positive. So then you need to write it like this. And as we get a little more advanced, I'm probably going to ask you to do that when the directions do not specify. They're all equivalent. Okay, I think that's enough said for now about those. We will keep practicing with them and you'll keep seeing them. Now, in Part B, distributive property of rational expressions with negative exponents. Okay, you've already been distributing things like this. Just now, there are going to be negative exponents. So we still use the distributive property. And read directions carefully. This time it says all exponents positive. Okay, so at first, it maybe it's personal preference. You can bring everything up and distribute, or you can make all the exponents positive and then distribute. I think for this one, I'm just going to go ahead and leave it like it is and distribute, and then go from there. I can show you varying ways of doing them with these examples. So I do the outside term times the first one from the inside, and since that outside one's a fraction, I'm going to write this thing over 1 so that my numerator lines up with the other one. Okay, and then I place the minus, copy this one again, times the second one. Okay, so I'm literally just copying them for now. And now let's see what we can do. I have a y to the 4th on the top and bottom here. I can cross cancel. Alright, then I only have 1's on the bottom, and here I have x to the positive 2 times x to the negative 2. When I add those exponents, that gives me x to the 0. And don't forget this 4. So the first term here is 4x to the 0. There's the minus. Now, let's see. X is on top, y is on bottom. There's no cross canceling. 4 times 3 is 12. X to the negative 2 times x to the 4. I use my product rule. I algebraically add these exponents. 4 minus 2 is 2. So x squared over, alright, y to the 4th times y to the negative 2. That's y squared. Okay, when I have x to the 0, that is 1. This is 4 times 1, which equals 4. Minus, and I look back at the directions. All exponents are supposed to be positive. They are, so nothing has to move. So this one is 12x squared over y squared. And that's it. I know these can be a little cumbersome, but they're good practice. Okay, use the distributive property to expand. Write the answer with all variables in the numerator. Everything's coming up, so I might as well do that right away. Or as I'm copying it, let's do that. So, we have x to the negative 2y times this first one, which is y to the 4th, x to the negative 2, because as I'm copying this, I'm bringing everything to the numerator, since that's where they're going to end up anyway. Minus, copy the front one again, and then this one, x to the 4th, y to the negative 2, because when I bring that up, it changes the sign of the exponent. Now in the first term here, I need to combine these. Here is an x and here's an x. I add their exponents. And then same for the y's. Place the minus. Then again, I add the exponents on the x's. 4 minus 2 is 2. And on y, negative 2 and 1 is negative 1. Look back at the directions. Numerator, they are, and it's been simplified as much as I can, so that is the answer to that. Okay. And the third one here, This time, they want all the variables in the denominator. All right, so I might as well take everything down as I'm copying it. So this one is 1 over k to the negative 2, b to the negative 1, because again, when I'm crossing that fraction bar, it changes the sign of those exponents, p to the negative 2, because that just stays there. All right, times, again, taking all this stuff down, a to the negative 1, b to the 1, I don't have to write that, but I can, and then k to the second, that one's not moving, it stays the same, minus, I should have written a little smaller. Okay, copy the first one, times the second one, but again, bringing all the variables down. That 4 stays where it is. The variables need to be in the denominator. Okay, so we have b, and then that p comes down, p to the negative 2. Okay, so now they're written, I can start combining things. 1 times 1 in the top, 1. 1 in the bottom. Here's a k to the negative 2 and a k to the positive 2. Adding the exponents, that's k to the 0. Alright, then I have b to the negative 1 and a b to the positive 1. Those are 0 and I add them. Did the k's, did the b's. Alright, then we have p to the negative 2, a to the negative 1, minus 4, because 1 times 4, over, no other k's, k to the negative 2, b to the negative 1 times b, that's b to the 0, p to the negative 2 times p to the negative 2 is p to the negative 4. Okay, now I just need to clean this up because I don't leave those 0 exponents. That can be simplified. Alright, that's just 1 times that stuff. So we have 1 over p to the negative 2, a to the negative 1, minus 4 over k to the negative 2, p to the negative 4. The variables are in the denominator where they wanted them, and that's all we can do. They are simplified. That is the end of the notes.